right, next up is Hooke's law. Hooke's law states that the force required to stretch or compress a spring is proportional to the amount of stretch or compression, and it's also proportional to the stiffness of the spring. And it turns out there is no there's no other constant that we have to worry about, so it's just the stiffness of the spring and the amount of compression or stretch. So you might hear this as like the stiffness constant or the spring constant, and this is the compression or the stretch. The only way to change out the K is to change out the spring. Even if you overstretch the spring, all you're messing with is the plasticity, not the stiffness of the spring. So this X here is probably what we're going to be talking about, this delta X. If you imagine a spring and we just lay it on the table and this was its natural length, if you decide to pull it, this is the amount stretched. If we compress it, that's the amount compressed. So we're just talking about the change in length here. So I'm not sure why it's called Hooke's law, because not all springs follow this pattern, but any spring that follows this is considered Hookean, if I'm saying that right. So basically, if we graph the force and the compression, so this is how hard we're pulling on the spring, and this is how much we've compressed it, or sorry, if we're pulling, this is how much we stretched it, then the force would scale linearly to the spring. So it doesn't, the stiffness kind of tells us the steepness of that graph. So little k, big K. But there are other relationships for different kinds of springs, where like conical and torsion springs. But we're mainly going to talk about these linear ones here. For the direction, if we've compressed the spring, so we're back over here. If we compress the spring, it wants to snap back to its original length. So the direction of the spring, or the direction of the force that the spring would be exerted, is always opposite the push or the pull on it. So if we compress it, it wants to snap back. If we pull it, it wants to snap forward or whatever. Basically, if we pull to the right, it wants to snap to the left. If we compress to the left, it wants to snap to the right. Before I leave you, the spring constant, we can figure out the units for that. Just with some simple algebra, it'd be the force divided by the compression. So the units for the spring constant would be the Newton per meter. So amount of force per amount stretched.